this final set of concepts that we're going to look at here are the last little volume and surface area formulas that you need to know. And again, bless you, it is just formulas that you need to be familiar with and memorize. Okay, and so we're going to start with spheres and hemispheres, or portions of these different solids. So the surface area for a sphere has a formula of 4 pi r squared. Again, there's no real trick to this. It's not really derived visually like we were able to do with the prisms and the cylinders and even the pyramids and cones. But this is your formula, 4 pi r squared. You just need to be able to apply it. And so here, just as straightforward as you can possibly get. If you're given a sphere, read carefully, because again, the biggest mistake is going to be finding the volume or mixing up the formulas for volume and surface area. So you see this question's asking for the surface area. You see it's a sphere, and it has a radius of 14. And so you can simply take 4 times pi r squared, and that's all you would need to do. Enter the formula as it appears. If you are doing the calculation separately, you can also do that. In this particular case, you would get 2,463.01. The units on this are also square units because it's an area. It was given as meters, and so you would use square meters if you had to label it. Hey, I want you to try the problem right below. Again, just adding like a slight layer of difficulty, but it's still pretty basic and straightforward. And can you find the, in this case now you're working backwards and using the information from the surface area formula to find the diameter. Again, more than likely when you're working through these questions, just like when you're finding the height or one of the other measurements in your solids, that it's often going to be an integer value. So expect to see an integer there. Doing the homework or the practice problems will help give you an idea of whether that's a decimal or integer value. Okay, so here, if we know we're dealing with the surface area, so surface area is 4 pi r squared. Notice that's 4 times the area of the corresponding circle that makes up sort of this reference. This is called a great circle here of a sphere. Okay, so if we take 400 pi and replace the surface area with that, and then isolate what we're looking for, divide both sides by 4 pi. The pi's cancel. 4 goes into 400, 100. And now when you extract your root, the square root of 100 gives you 10. Now, is this the correct answer? Is the diameter 10? No. The diameter is not 10, right? What we found to be 10 was the radius, which means the diameter is going to be what? Twice the radius, or 20. Okay, so be careful, again, make sure that you have the correct formula and make sure that you're solving for the piece of information that's being asked, in this particular case, the diameter. All right, and then the last question here, we've seen it in some of the other solids of rotation, and that is if I give you the polygon or the two-dimensional shape, in this case a semicircle, that's used to form this sphere when it's rotated, you need to be able to find the surface area and volume for that. So try this last question here on this slide. All right, so here you have this semicircle with the diameter of 44. It's going to be rotated about that diameter. So when the rotation occurs here, it comes all the way around and back to form that total sphere. And so if the diameter is 44, when we are calculating the surface area for this, the surface area is 4 times the area of a corresponding, or a circle with the same corresponding radius. And so it's just a matter of finding what is the radius here. Well, if the diameter is 44, that means the radius is half of that, or 22. So there would be your calculation. And if you plug this in, 4 pi times 22 squared, and you would get your answer here of 6,082.12. The units are meters. Again, we're dealing with the surface area, so it is square meters. But either of those would be acceptable ways to enter your solution. All right, so that's surface area. The final formula that you're going to need to use for this semester, this chapter and semester, is the volume formula for a sphere. And the volume formula, again, is one that there are some relationships between the volume and area formulas. But if you're looking for the volume of a sphere, it's 4/3 pi r cubed. Okay, a couple things to help remember that this is the case. Volume is a three-dimensional measurement, so the power of r is 3. Coming back here, surface area is a two-dimensional measure, so the power is a 2. And so that would be one way to help remind you which one belongs to which. Okay, but this is your volume equation for a sphere. All right, so see if you can extend this first question. So this one is asking you to use what you know about the surface area, find the radius, and then plug that radius into the volume of a sphere. So see if you can calculate this. This would be one of the more challenging versions of questions that you will likely see. So this is a problem that requires you to use both the surface area and the volume equations. So the first is the surface area is going to be 4 pi r squared. Again, it's 4 times the circle with the same radius. And if you are told what that measurement is, you can set that equal and solve. And so notice here, as you are working through, do the same process, divide by 4 pi to isolate your variable, and then extract your root. So this right here, this whole calculation is our radius, our r value. And so if we look at what that is, so this is the square root of 2846.31, and that's all over 4 pi. Notice the 4 pi is also under the radical, and they're both in the denominator of that. So you get this value. The radius is approximately 15.05. When you use calculations, you have to use the exact calculation as long as you possibly can. So if we now go back in and take our volume formula, which is 4/3 pi r cubed, and we plug that number that's on the calculator into this, you need to use the whole number. So you're either going to plug this whole value specifically in. So if you enter your answer as a calculation here, you would enter it as this. Okay, so this would be the entry on my Open Math if you are going to enter your answer as a calculation. If you want to do the calculation separately, so let's say you're using this separately, the way that you can kind of call on this number. So even if you try to highlight this and copy and paste it, it's still not quite the exact number. But if you go in front of your calculation and you give it a variable, so since this is representing our radius, let's just go ahead and call it r, and just say r equals that. What happens then is anytime I type r here, it pulls up the exact value. Okay, so now we've assigned the exact value for r. And so if I want to calculate what is this overall volume, I would take 4/3 pi times, and I just put r cubed. Okay, and it's going to plug that in, and this is your exact answer, which you, when you write your final answer, you can approximate. Oops. So here you would get, 14,278.98 approximately. The units here are centimeters. Volume is a three-dimensional measurement, so we would make sure we are using cubic units for that. So either of those would be the, again, acceptable ways to enter your answer for that. All right. Last problem here on this slide. See if you can do the same solid rotation using a given semicircle, and can you find what the volume would be on that? So notice this is a little bit different than the one from the surface area question that gave you diameter. This time it's giving you radius. Make sure you label your pieces correctly on that. And when we form our solid of rotation, we rotate it about this diameter, again, to form that solid. And we do need to know the radius for it. The radius was given, and so it's simply 4/3 pi r cubed, where our r value was 11. So again, we can enter our calculation, which is what I would encourage you to do. I prefer seeing that anyway. And if you type it in individually, you get your answer to be 5575.28. The units are centimeters. Again, volume is three-dimensional, so it's cubic centimeters. All right, so those would be your calculations for this. All right, we have one final slide that's just sort of a culmination of the volumes that we've looked at, focusing on like portions or combinations of these, especially these solids of rotation. So let's look at these last little, the last little bits here. Okay, when you're looking at the volume of a hemisphere, hemisphere means half of a sphere. Okay, so would it make sense that the volume of a hemisphere is exactly 1/2 that of a corresponding sphere? If you looked at this, the whole thing here, is the top half of this hemisphere, or this top half of this sphere, have the same volume as the bottom half? Yeah, each one is just half of a whole one. So the way that you would calculate that is you just take the fraction of that. So it's 1/2 of 4/3 pi r cubed. Okay, and you can simplify this. You can reduce it down and just memorize it as 2/3 of pi r cubed. But to me, I will always kind of set it up this way, just because it's one. You don't have to try to remember a separate thing. You just know a hemisphere is 1/2 the volume of a corresponding sphere. Now, even though I don't have it on here, what would the surface area for a hemisphere be? Okay, it would be, let's look at it like sort of visually. We have that curved surface, right? But we also have the circular base. Right, so this is the lateral surface, and then we have the base. And so the lateral surface is just half of the curved portion of a sphere. So this would be 1/2 of 4 pi r squared. And then the base is just a circle itself. It's pi r squared. And so notice what happens here. 1/2 of 4 is 2. 2 pi r squared plus 1 pi r squared gives you the formula, which is 3 pi r squared. Now, again, it's not asking you to find the surface area of a hemisphere, but if it were, or if you see something like that, you need to take half of the curved surface plus add that base, the bottom circle, back to it. All right. So notice a couple things here. We'll do the hemisphere question first and then come back and look at these combinations of building different shapes with portions of the solids. Okay, so try this first one. Again, it's just a straightforward application of your volume formula. So you can think of a hemisphere as having a volume of 2/3 pi r cubed, or again, what you'll see me do is just half of that of a corresponding sphere. So 1/3 pi r cubed, or 1/2 of 4/3 pi r cubed. I can reduce that, plug in my radius of 27. And there is your answer. If you're entering it, you can leave it as 1/2 of 4/3 pi times 27 cubed. And you get your answer, 41,223. Says to round it to at least the nearest hundredth, which is 2 decimal places, so 98. But again, if I left it this way, I can choose either the calculation, which is what I would prefer, or the calculated value. It is volume, so it's a three-dimensional measurement, so it's cubic meters if you were labeling the units. All right, the final type of questions, again, that are on the more challenging side are going to be questions where you're being asked to find the total volume of some combination of solids. So I'm going to talk through this first one and then have you try the last one. So if we look at this problem right here, this cone, or this ice cream cone or snow cone. And when you're looking at this, what you have here for your volume is you have a hemisphere and you have your cone, right? So you're adding these together. So you'll usually see me set it up with visuals and then put the formulas. So a hemisphere is 1/2 of 4/3 pi r cubed. And a cone, when you're finding the volume, is 1/3 capital B, which is pi r squared times h. So this is your formula when you're figuring it out. And then it's just a matter of finding two elements, right? You have two measurements you have to find. The radius is 5, and the height of your cone, which was given as 28. So if we just plug in what we have, the half and the 4 cancel. Oops, leaving 2/3 pi times my radius of 5 cubed plus 1/3 times 5 squared times the height, 28. And once again, I encourage you, just enter your calculation. And if you are actually multiplying that out, you can also combine these and get your answer. Make sure of the 1/3. That, again, would be the most commonly missed part to that. All right, and so when you type all those in, you get your total volume to be 994. 0.84 approximately. The units are feet. It's a volume, so it's cubic feet if you had to label. And so either of these are acceptable forms of your answer. All right, so try the last one, the cylinder within a hemisphere. See if you can calculate the total volume there. So here, your volume is the hemisphere plus the cylinder. Okay, and so you take each one's volume formula individually. So the hemisphere is 1/2 of a sphere, so 1/2 of 4/3 pi r cubed. A cylinder is capital B, capital H, where capital B is a circle. The area formula for a circle is pi r squared times h. So here's your calculation. Plug in your values. The 2 and the 4 cancel. You get 2/3 pi times my radius. The radius of this hemisphere is the same as the radius of your cylinder, so 6. Plus pi times 6 squared times the h value. The height of that cylinder is 26. So once again, you have the choice of entering your answer as a calculation, or if you do the calculations. And you get your total volume here to be 3392.92. The units are centimeters. Volume is 3-dimensional. And so that would be your other way to enter your solution.